Dear students, in the previous session we discussed some problems that is related to the nth sum of n terms of an arithmetic progression. So in this class also we are going to solve some more problems. So let us consider the first example. Find the sum of the first 1000 positive integers. So what is the question given? Find the sum. Find the sum of n terms of an arithmetic progression. What is the formula? Sn equal to n by 2 into 2a plus n minus 1 into d. So first 1000 positive integer. First you have to write the list of numbers. So Sn equal to 1 plus 2 plus 3 plus so on up to 1000. Find the sum of the first 1000 positive integer. Now we have to find the sum of the each terms of the given list of numbers. So the list of numbers are in AP because the common difference is the same. So here first term a equal to 1 and common difference d, second term minus first term equal to 1. Then number of terms. So in this list of numbers, how many terms are there? 1000 terms are there. So we have to find the sum of the first 1000 positive integers. So what is the formula? Sn equal to n by 2 into 2a plus n minus 1 into d. Now substitute the values. Sn means s 1000 equal to n 1000 divided by 2 into here the value of a is 1 plus n 1000 minus 1 into d. Common difference is also 1. Now simplify. So equal to 2 ones are 2 500s are. So 500 into 2 into 1 2 plus 1000 minus 1 that is 999 into 1 999. So 500 into 999 plus 2 means 1001. Now multiply 500 into 1001. So the answer is, so this is the sum. So sum of the first 1000 positive integers by using the formula Sn equal to n by 2 into 2a plus n minus 1 into d. So this can be solved by one more method. So the formula, you know that if the first term and the last term given, how to find the sum? By using the formula Sn equal to n by 2 into a plus an, first term and the last term given. So or one more method, Sn equal to n by 2 into a plus an, a plus an, a first term, an that is the last term. So how many terms are there? 1000 terms. So 1000 divided by 2 into a means first term 1 plus an last term that is 1000. So 2 ones are 2 500s are. So 500 into 1001. So the sum is, so this is the sum of the first 1000 positive integer. Go through the next question. Find the sum of the first n positive integers. Just compare it with the previous question. In the previous question, find the sum of the first 1000 positive integers. What about here? Find the sum of the first n positive integers. First you have to write the list of numbers. So Sn equal to 1 plus 2 plus 3 plus so on plus n. How many terms are there? N terms. So find the sum of the first n positive integers. So the list of numbers are in AP. So a first term 1, common difference d equal to second term minus first term equal to 1. How many terms are there? So n equal to n. Number of terms is n. Here the first term is 1. What about the last term? Last term an is also n. Last term is n. Now how to find the sum? If the first term and the last term given, what is the sum of n terms of an arithmetic progression? What is the formula? Sn equal to n by 2 into a plus an. A plus an. So this is the formula to find the sum of n terms of an arithmetic progression if the first term and the last term given. Now substitute the value. N, number of terms is n. So n by 2 into a, first term 1 plus an is a last term, that is n. Or we can write it as Sn equal to n by 2 into 1 plus n or n plus 1. So, this is answer. Sn equal to n by 2 into n plus 1. So, this is also one type of the formula to find the sum of the first n positive integer. So, therefore, the formula is the sum of the first n positive integers. N positive integers is given by Sn equal to n into n plus 1 by 2. So, this is the formula, or n by 2 into n by 2 into n plus 1. What is the formula? So, the sum of the first n positive integers. Sum of the first n positive integers is given by Sn equal to n by 2 into n plus 1. Here n is the number of terms. Move on to the next question. A manufacturer of TV sets produced 600 sets in the third year and 700 sets in the 7th year. Assuming that the production increases uniformly by a fixed number every year. So, you have to find number 1, the production in the first year, next the production in the 10th year, and the total production in the first 7 years. Understand the question correctly. So, what is the question? 600 sets in the third year and the 700 sets in the 7th year. Assuming that the production increases uniformly, therefore are in AP. The terms are in AP. And the production in the first year. Production in the first year means we have to find the value of A. A is nothing but the first term. And the production in the 10th year. 10th year means n equal to 10. And the total production in the first 7 years. Total means we have to find the sum. Sum of the first 7 terms. So, first 7 years. So, here the given 600 sets in the third year. Third year means that is a third term. Third term is denoted as A3. A3 equal to 600. And 700 sets in the 7th year. 7th year means A7 equal to 700. Now, A3 means, just recall the general form of the arithmetic progression. First term A, second term A plus D, third term A plus 2D, or A3 we can write it as A plus 2D equal to 600. So, let it be equation number 1. And how to write A7? 7th term. 7th term is written as A plus 6D equal to 700. So, let it be equation number 2. On solving equation 1 and 2, we get the value of A as well as D. So, solving equation 1 and 2, A plus 2D equal to 600, equation number 1. And A plus 6D equal to 700, equation number 2. So, these are the pair of the linear equations in 2 variables. Now, eliminate any one of the variable, either A or D. Now, subtract equation 1 from 2. So, plus becomes minus, here also minus. So, plus A minus A 0. So, this method is known as elimination method. So, plus 2D minus 6D minus 4D equal to 600 minus 700. So, minus 100. Next, so D value, so D equal to minus 100 divided by minus 4. 4 ones are 4 25s are. So, therefore, D equal to 25. D equal to 25 means a common difference. So, next, how to find the first term? By substituting the value of D in equation 1 or 2. Now, substitute the value of D in the equation 1, A plus 2D equal to 600. So, A plus 2 into D value 25 equal to 600. So, A plus 2 into 25 50 equal to 600. So, A equal to 600 plus 50 becomes minus 50. So, therefore, A equal to 550. So, the first term 550 and the common difference D equal to 25. Once again go through the question. What is the question given? Find the production in the first year. Find the production in the first year means that is first term. So, the production in the first year is 550. So, therefore, the answer for the first question, the production in the first year is 550. You have to write the sentence, the production in the first year equal to 550. Next, what about the second question? So, the second question, the production in the 10th year. Production in the 10th year means n equal to 10. So, formula an equal to a plus n minus 1 into d. An means that is the 10th year, a10 equal to a first term 550 plus 10 minus 1 into d 25 equal to 550 plus 9 into 25. So, which is equal to 550 plus 5. So, 225. What is the sum? 550 plus 225, that is 755. So, that is A10. A10 means the production in the 10th year. So, the production in the 10th year is 755. Next, move on to the next question. The total production in the first 7 years. Total production in the first 7 years means, what is the meaning? Total means a sum. So, you have to find the sum. So, the third one, Sn equal to n by 2 into 2a plus n minus 1 into d. Now, substitute the value Sn, first 7 years, that is S7 equal to 7 by 2 into 2 into a. A is the first term, 550 plus n minus 1, 7 minus 1 into d value. So, d value 25. Now, simplify. So, 7 by 2 into 550 into 2, 1100. So, plus 6 into 25. So, which is equal to 7 by 2 into 1100 plus 150. So, which is equal to 7 by 2 into 1100 plus 150, 1250. Now, 2 ones are 2, 6, 25s are. Now, multiply 7 into 625. So, the product is 4375. 4375. So, the total production in the first 7 years. Total production in the first 7 years is 4375. Next concept of the arithmetic progression, relation between the nth term and the sum of n terms of an arithmetic progression. Nth term is denoted as an, and the sum of the n terms of an AP, sum of n terms of an AP is denoted as Sn. So, the meaning, we have to find the relation between an and Sn. An and Sn. Now, let us consider the nth term of the arithmetic progression an equal to 2n minus 1. Nth term of an arithmetic progression an equal to 2n minus 1. Now, n equal to 1. So, a1 equal to 2 into 1 minus 1. So, 2 into 1, 2 minus 1 equal to 1. So, next a2. So, a2 equal to 2 into n equal to 2. So, here n equal to 2. So, a2 equal to 2 into 2 minus 1. 2 into 2, 4 minus 1 equal to 3. And next n equal to 3, a3 equal to 2 into 3 minus 1. 2 into 3, 6 minus 1 equal to 5. And then n equal to 4, a4 means a fourth term, 2 into 4 minus 1. So, 8 minus 1 equal to 7. So, the nth term of an AP. So the relation between nth term and Sn, sum of n terms. Now S1, what is the meaning S1? S1 means sum of the first term. Sum of the first term. So first term is denoted as A1. So S1 equal to A1 equal to 1. I think it is clear. So next, A2 means a second term. So next, find S2. S2 means sum of first two terms. S2 means the sum of the first two terms. Which are the two terms? A1 and A2 are the first two terms. S2 means A1 plus A2. Sum of the first two terms. So A1 value 1 plus A2 value 3 equal to 4. And next find S3. So S3 means, what is the meaning? Sum of first three terms. Sum of the first three terms. Which are the first three terms? A1 plus A2 plus A3 equal to. So A1 is 1 plus A2 is 3 plus A3 is 5, which is equal to 9. So S1 first term, sum of the first term, that is 1. S2 sum of the first two terms, 4. And S3 sum of the first three terms, that is 9. So next, find S2 minus S1. So find the value of S2 minus S1. S2 minus S1 means sum of the first two terms minus sum of the first term. So S2 is 4 minus S1 is 1, that is 4 minus 1 is 3, which is equal to A2. Which is equal to A2. So since S2 minus S1 equal to A2. S2 minus S1 equal to A2. And next find S3 minus S2. What is the meaning? S3, sum of the first three terms minus sum of the first two terms. So S3 value 9 minus S2 is 4, 9 minus 4, 5, which is equal to third term. So third term A3. Or since S3 minus S2 equal to A3. Look at here, S2 minus S1 equal to A2. Sum of the first two terms minus sum of the first term, which is equal to second term. Here sum of the first three terms minus sum of the first two terms, which is equal to third term. Our aim is to find the relation between sum of n terms of an AP and the nth term. So from this we conclude that S3 minus S2 equal to A3, or S4 minus S3 equal to A4, or we can write it as Sn minus Sn minus 1 equal to An. So this is the relation between Sn and An. Sn minus Sn minus 1 equal to An, or nth term of an arithmetic progression. Listen carefully. Nth term of an arithmetic progression is the difference of the sum of the n terms and the sum of the n minus 1 terms. What is the relation? Some relation between the nth term and the sum of the n terms of an arithmetic progression. Sn minus Sn minus 1 equal to An. So I think it is clear. So dear students, practice the problem which is given in your textbook, and we will continue in the next class. Thank you one and all.